All right, hello everyone. Today we'll be talking about LeetCode number 130, surrounded regions. This problem states that given a 2D board containing char X and char O, capture all regions surrounded by X. A region is captured by flipping all O's into X's that in that surrounded region. So there is an example here. Let's head over to the explanation first. So surrounded regions shouldn't be on the border. This is very important, which means that any O on the border of the board are not flipped to X. Any O that is not on the border and is not connected to an O on the border will be flipped to X as well. Not as well, but two cells are connected if they are adjacent cells connected horizontally or vertically. That means there are only going to be 4 directions, not 8. So let's head over to our whiteboard and see the example. So this is the example they gave us. As you can see, because there are 4 directions, these two are not connected. So that is not connected. And as you can see, these 3, which are surrounded by X's, gets converted to X's. And one main takeaway from this is that this is on the border. It doesn't get flipped. And if I were, let's just say this X is now an O. So it's an O. Then this one would also stay an O because they're connected and they don't get flipped. So I'm going to re-emphasize this a lot. This O is on a border, and any O's that are connected to the border will not get flipped. And this is going to be one of the main strategies to solve this problem. So let's take a look here. The solution to this problem is very simple. All that it requires is to fill the surrounded regions with X. And I'm going to reiterate here, another word for surrounded regions is regions not touching the border. Because of this, all it takes to finish the problem is to mark the O's connected to the border with something, then mark the leftover O's with X, and then go back to remark the something to an O. After that, the transformation will be complete. So if we look at this problem here, let's get rid of all our markings. Okay, so if we look at this problem, what you can see here is that first we're going to mark the O's that are on the border. So this one, let's just mark it to a star. Then once we finish marking this one, what we need to do is we need to mark this one to an X, like these. Then what we need to do is to remark the star into an O, because the final state needs to be an O and not a star. So we need to remark it there and we'll be finished. So let's head over and then code the solution. First, what I'm going to do is I'm going to make a function, a DFS function to be more specific, that marks all of the chars that you want into a different chart. So what I will do here is I'll take in a char that is the target. Then what I will do is it will also have another char that is the to fill, let's call it. What the to fill does is to fill the target with this new to fill. Then it needs to go 4 directions. So let's go up. Oops. It needs to go left. It needs to go right. and it needs to go down. So these are the 4 directions, and because we're going to be operating with a matrix, we can just use the I and J indices. So things like I plus 1 J, J plus 1 I minus 1 J, J minus 1 I. These 4 transformations will get us to the horizontally and vertically adjacent cells. So let's get going on the function. I'm going to call this function a I'm going to name it DFS because it is a DFS function, and it'll take in the board. And to clarify here, the reason why we can take in this board, and once we modify it, it'll be the same as this board, is because Java actually treats these structures as an object. Normally, you would think that this would be a primitive type, which would actually copy it, but Java treats these data structures as an object. So that's one thing to note, which means that anything made in the array that gets passed in will also be made on the array in this function here. So we need a board, we need an I index, and we need a J index. We also need our target and our fill. Okay. Now what we need to do is, obviously, if it's out of bounds, then we don't want it. So if I is less than 0, or I is bigger than board.length, or J is smaller than 0, or J is bigger than, it's bigger than or equals to, my bad. So let's go fix that. Okay. If that's the case, we'll just return out of the function. Now, if that's not the case, we need to check whether the target is, whether the char at the position is equal to target. So, that's a lot of typos today. So if board at I and J is equal to target, we will need to mark it. So board at I and J will now be equal to the 2 fill. And then we'll also DFS to the other ones. So I, J minus 1, then we need to pass in board, J minus 1 target, and 2 fill. Okay, and then I'm gonna copy this 4 times. You could make an array and then loop through, but it's only 4, so I'll do it manually. And alright, so that will run to call the adjacent cells. As you can see, I and J minus 1 refers to the left. I and J plus 1 refers to the right. I plus 1 J refers to down. I minus 1 J refers to up. So that's what's going to happen. Now, if that's out, we'll just return. Okay. So now now that we have this function finished, all we need to do is to go in and do some operations on the board. Now, first things first, if the board's length is equal to 0, we can just return nothing. Now, I'm gonna create a new char. Sorry, not a new char. A char that's called to fill, another to fill, but since that's a little ambiguous on the naming, I'm gonna say new fill. I'm gonna set this to what we had here, which is a star. So what this will mark any O connected to the border with a star. Now we need to loop through the border. So we need our 2 nested for loops here. Then what we need is a condition. If I is equal to 0, that's the first row. Or if I is equal to board.length minus 1, or j is equal to 0, or j is equal to board at 0 length minus 1. If that condition is true, we'll run the DFS on the board at I and at j. We're looking for O's, and we need to fill it with the new fill. Now this will fill the board. The O's that are touching the border with new fill. What we need to do now is to fill the remaining O's with X's. So I'm just gonna copy this, and instead of this condition here, what we're checking is that the board at I and at j needs to be at an O. If that's the case, we will run the DFS, but this time we have one more condition to check. We can make it shorter by saying it's 1 because we don't need to check the borders. We only need to check starting from row 1 and column 1. So that's one adjustment, and I made a typo here. This is supposed to be the board at 0's length. Okay. Now we need to adjust this function to fill it with an X. After this for loop, one last thing to do is to refill the star into an O. And we actually have to go back to 0, 0 here. And what we can do is, if that is equal to new fill, then we'll fill this new fill with O. And that's basically what the program does. Let's see if it works. Yeah, this should have been single quotes. And then, oh, I missed a equal sign here. Okay, looks like it works. Let's submit and then see if it passes. Good, it does. 3 millisecond runtime. Let's see how we did. Relatively fast program. I guess they did the same thing, but the reason theirs was faster is because they had some better condition checking here. They marked it E, I'm guessing. Oh, yeah. So they just did some pretty good condition checking. Same DFS function. Basically the same as what we did, but I guess they made the solution faster by doing these little more elegant modifications to the program. But yeah, that's how you do surrounded regions. This was a recursion video and a matrix traversal video. If you would like to see more of those videos, make sure to check out my playlists on those. If you just want to see more LeetCode videos or projects such as Sudoku Solver, go check out my channel page. And last but not least, if you like this video, like it and remember to subscribe to my channel. Thanks.